Good evening, students. How are you all? Hope you all are doing well. So, preparing for your board exams? So, hope all of you have started your practice with your first and second chapters revision has been already done. So, hope all of you are practicing for them. So, today we'll start up our new chapter, which is chapter 3, pairs of linear equations in two variables. So, this is going to be a chapter for today. So, how many of you feel this chapter easy or difficult? Send me in your chat box. And how many of you have started your preparation? How many of you have revised your chapter 1 and 2? Are doing it? Text me in the chat box. Good. Very nice. Good to see. Perfect. So how many of you feel this chapter to be easy or difficult? If it is easy, type E. If it is difficult, send me D in your chat box. Good. Good. Very good to see. And I expect everyone in the class to send your responses. Perfect. Good to go. Okay. Okay. Some of you have a doubt of where to send your chat, personal chat. Send it to MTG Learning Media, which is named as host. So send your personal chat messages to the host. Okay. Fine. So let's start our chapter 3, which is pairs of linear equations in two variables, which is going to be a chapter for today. First, let's have a brief look of what this chapter is and what is the weightage of this chapter and all those things. Then we'll move on to the chapter. So first, coming to the chapter weightage, here you can see this chapter is again belonging to the category of algebra, where you have a complete weightage of 20 marks. So on an average, you can expect 5 to 6 marks from this chapter as well. So this is going to be a chapter 3 with a weightage of 5 to 6 marks. Now let's have a look of what are the subtopics of this chapter. So here you can see the main subtopics of this chapter are the first and foremost, we are understanding what pair of linear equations in two variables are. Then we will see how to make the graphical representation of these types of equations. Later, we will see how to solve these linear equations. These are the three topics that we are going to study in this chapter. And coming to the weightage of various topics, here you can see since 3.1 is just an intro part, 3.2 is a graphical representation. So graphical representation is making out the graph of the given equations, which is going to be a lengthy process. So all your long answer type questions are going to be from 3.2. This is the maximum occurrences probability that you have for 3.2 to occur in long answer type. Coming to the short answer type, MCQs, assertion and reasoning, on all those categories, short answer type 1 and 2, very short answers, anything, whatever the other sort of questions are there, you have a maximum probability to occur in 3.3. That is, how do we solve the given linear equations algebraically, and what are the various conditions that we have for solving them? All those belongs to 3.3. So this is how this chapter is being weightage. So if you want a complete of 4 to 5 marks in your hand at a go, you should be very good at graphing the given equations or analyzing the given question and then graphing or studying the graph, whatever it is. Now, if you don't want a max of 5 marks at a go, and if you want it in bits and bytes, then topic 3 is going to help you. So this is how you solve the equations. What are the relation between the various terms in an equation basing on the type of graph it occurs. This is all about in 3.3. So you can prepare for both the parts. You can get your score. So as I've said, it could be 5 to 6 marks. So hardly if you get a very short answer or a multiple choice question and a long answer, still you get 6 marks. Or you may get a very short answer with a short answer with some multiple choice, still 5 to 6 marks. So scoring could be anywhere. So hope you have understood the brief weightage of the chapter. So what are we waiting for? Shall we go on to deep, quick recap of this chapter? Here we go. First and foremost, let's understand what are linear equations in two variables. And if you have a pair of it, how are they called for? So here you have a pair of linear equations in two variables is a collection of two linear equations in same pair of variables. Now, if I consider any two variables for suppose x and y, and if I frame a linear equation in it, such linear equations, a pair, that is two linear equations, if I consider together a pair, then we call it as a pair of linear equations, which we also call it as system of linear equations. There is other names also for this, which is system of linear equations. Now, here is an example you can see. 3x minus 2y plus 4, 3x minus 2y is equals to 4, and 2x plus y is equals to 5. So here you can observe the variables used in both the equations are same x and y. So we call it as system of linear equations or a pair of linear equations. There is other name still, we call it as simultaneous linear equations. So simultaneous linear equations also we call. So anyway you call, we are going to solve it. Now, when you have two equations with you, definitely by solving it, you can get the values of x and y. And how are we going to solve it? How are the quotients of x and y related here? This is all about this chapter. So this chapter is about two things. One, from the equations, deducting the values of x and y. The other thing, basing on the way the coefficients are there for x and y in the given equations, what type of graphs is going to occur for those equations. This is the other category. So let's go deep into the topic. So general form of a pair of linear equations in two variables. So the above one is just an example. You should know what is the general form of it. So here you go. A1x plus B1y plus C1 equals to 0. A2x plus B2y plus C2 equals to 0. So here you can see again, these are the two linear equations in the variables x and y, where A1, B1, C1, A2, B2, C2, all of these are real numbers. And always remember, here, whenever you are framing a linear equation in two variables, you should always be careful that the x coefficient and the y coefficient together should never be 0. That is, either of them can be 0. That's okay. But both of them should never be 0. What happens if both are zeros? See, if both are zeros, this part will become 0. This part also will become 0. Only the constancy. For suppose if it is C is minus 5. So minus 5 equals to 0. It makes no sense. And even it is not an equation. So for that reason, in any linear equation in two variables, both x coefficient and y coefficient should never be 0 together. How can we say this big statement in a symbolical mathematical form like this? A1 square plus B1 square should not be equals to 0. A2 square plus B2 square should not be equals to 0. What is the meaning of it? Now, for suppose A is any integer. If you are squaring it, it becomes positive. B is also any integer. If you're squaring it, if it is positive. If A and B are non-zeros, then only this both becomes 0. I mean, a positive. And if you add, it will again be a positive value. But if this is 0, okay, the other is a positive value, which again leads to an ultimate positive. Same way, if A is also positive, you can solve it. If both are zeros, you get the sum is 0. So for that reason, The simple meaning of this expression is nothing but x coefficient and y coefficient together should never be 0. That means if both of these become 0, the squaring of this also will become 0, leading it to be 0. This shouldn't happen, is the condition. Okay. Now, a pair of values x and y which satisfies the given equations simultaneously is said to be the solution of the given pair of equations. Okay. So what is the meaning of it? As I have told you, this is a linear equation in two variables. This is also a linear equation in two variables. Now, in class 9, you would have been studying. Whenever you represent a linear equation in two variables in the form of a graph, you just get a straight line on the graph paper. The straight line could be in any direction with whatever the inclination, no matter what. It is just a straight line. And since you have two variables in it, you can replace infinite pair of values which satisfy this equation. Now, for suppose if I replace x value 0 in this, what happens? If I replace x value 0, it becomes y value minus 2. If I replace x value 1 in this, what happens here? It becomes y value as 1. So, sorry, if I replace x value as 1, it is 3 minus 4 minus 1. So, you'll get it as 1 by 2, minus 1 by 2. So, likewise, if you keep on replacing one variable value, you'll get a new other variable value, which gives you infinite pair of solutions for a given single linear equation. Are you able to follow me? For a given single linear equation, you have infinite pairs of values which satisfy them. All of these points, if you join on a graph paper, they make up a straight line. And this equation becomes the address of this straight line. But when you take up two equations together, of course, this equation also has infinite points satisfying it, making up a straight line. The other equation also has infinite points making up a straight line, which is being satisfied by it. Now, if these two lines have anything in common, or there is one particular point which is being satisfied by these two lines. For suppose the other line is 2x plus y equals to 5. These are the two lines which have been graphed. Now, if these two lines have any common point, that common point is said to be the values of x and y which satisfy both the given equations, which we also call it as solution of the given pair of linear equations. Okay. Now, when is the solution possible? How is it possible? When is it not possible? We will study in detail. So one important point to remember, what is it? A pair of linear equations in two variables is also called as system of simultaneous linear equations. So this is what I've been telling you. So you call it as simultaneous equations, or we call it as system of linear equations. Whatever you call it, they are said to be, we are discussing a pair of linear equations only. So here we have solution of pair of linear equations. What is this? Just now I have been telling. When you have two linear equations, there should be a common point, or there should be a value of x and y which satisfies both the equations. Such a value of x and y are said to be a solution of this linear equation. There are various methods of solving this linear equation. How do we solve it? First and foremost, by the method of graphing. As I've told you, your 5 marks questions would be from this graphic category. So if you are solving the equations to find the x and y values, your long answer type questions would be in this category. If you are using the algebraic method of solving the equations or relating its coefficients, whatever it is, it comes to the other category, which is algebraic. In this algebraic method, again, there are various methods to be used to solve the equations to get x and y values, which is substitution method, elimination method, and cross multiplication method. Cross multiplication method is very rarely used depending on the situation, and ultimately it gets merged into this both. So today we will study about what is substitution method and elimination. Now, first and foremost, let's see how to make a graphical solution of a pair of linear equations. Now I have a pair of linear equations with me, and I have to find the graphing of this picture. And how will I do that? One second. The graph or geometrical representation of a pair of linear equations is a pair of straight lines with three different possibilities. Now, as said before, when you have two linear equations, you get two lines on the graph sheet. Okay. After getting two lines, how are these lines going to be? There are three different possibilities for that. What are those? The three possibilities are if the lines are intersecting. If the lines are intersecting, then the coordinates of this point where the is the solution of this system of equations. Now, once two lines are intersecting like this, if they are intersecting like this, the point where is this intersection happening? This point is said to be the solution of these two equations. Now, this is equation 1 graph and this is equation 2 graph. These both graphs are meeting at this point. So, this will be the solution of this equations. And there will be only one solution. Why? Because when two lines intersect, they intersect only at one point. So, they have only one solution. The second scenario is going to be something like this. When the two lines are not intersecting, but they are parallel. Once the two lines are parallel, where will the lines be meeting? There is nothing in common. Then how will you be able to find the x and y values? You can't find out. So, if the graph of your system of equations which you have represented on the graph paper are parallel lines, then you have no solution for that. So, that is what mentioned there. It has no solution. It has no solution. Now, moving further. Third scenario. The graph shows coinciding lines. That is, one line will be occurring over the other line. Because it is a straight line, so you can extend it how much ever you want, no matter what. So, the third scenario is when the lines are coinciding lines. In such cases, you can observe, once the two lines are coinciding, what is the thing happening over there? All the points of the first line are also the points of second line. So, they have infinite solutions. All these infinite solutions will be common for the first equation and the second equation as well. In that case, they have infinite solutions. So, again, remember, when you represent two linear equations, that is a system of equations in a graph paper, if you find them as intersecting lines, they have only one solution. If you find them as parallel lines, they have no solution. If you find them as coinciding lines, then they will have infinite solution. This is the basic pattern or the nature the equations possess. Now, to check whether the given lines are the given pair of equations represent intersecting parallel or coinciding lines, first and foremost, we should know how to plot them or draw them on the paper, graph paper. So, how can we do that? So, to represent any linear equation on a piece of graph paper, the way that you can do is you need to plot the points at least two in count, not more, 2 or 3. And those 2 or 3 points, if you join, then you'll get the respective straight line. And how can I get these points? Now, for example, you want to frame, draw the graph of the line. Like, let the equation be, for suppose, x plus 2y is equals to 6. Now, you want to graph this. So, you can take different values of x. You'll get corresponding values of y. So, all those trying is not easy. So, simply, first take x value 0. Then what will be the y value? 3. So you get an ordered pair 0, 3. So this is a point on y-axis. Now if you place y value 0, you'll get the concerned x value as 6. So the concerned ordered pair is 6, 0. So on the graph paper, you can mark this 6, 0 on x-axis, 0, 3 on y-axis. Join these both points. You are getting the required straight line, which is x plus 2y is equals to 6. So just by choosing 2 points on the graph paper, by joining them, you can get the required straight line represented. So you can choose any values for x and y, no matter what. But the easiest and the simply solvable values are taking x0 to get the point on y-axis, taking y0 to get a point on x-axis. Join both, you get it. And preferably, I suggest you take one more arbitrary point, take 3 points. Why do I say that is? Of course, 2 are more than enough. Sometimes, if you are doing any calculation error in this both, you will get a wrong line. Your line representation would become incorrect. In such case, if you take up a 3rd point, that would give you a verification. Now, suppose if I'm taking the point x value as 2 in this case. Now, if I take x value as 2, what will be the respective y value? Again, 2. So I'll get my ordered pair 2, 2. So if you're joining these 3 points by a single straight line, that means your calculations are right. If one point is somewhere here, the other 2 points are joining here. That means the 3 points are not in the straight line, which means you have made somewhere the other way mistake in the calculation. So for that reason, you can choose 3 points for your safer end. If not, if you're good at calculations with accuracy, go for 2 points. One on x-axis and one on y-axis. This is the tip how you can make your problem, graph problem error-free. Okay, so we have understood how do we graph it, what are the stages that we have. First and foremost, take any 2 points for every line, find their coordinate points, represent it on the graph paper to get every individual line. Secondary, where are the lines been meeting? Like if what sort of possibilities been occurring? Are they meeting at one point? Are they not meeting at any point? Are they coinciding one over the other? Basing on it, how many solutions it has, we can decide. Now, there should be another method. Not all questions being solvable using graph method. We can't keep sitting and trying every question in graph. So there should be other method also, which is algebraic method. Now, in this substitution method, what is substitution method? Substitution method says that we can express one variable in terms of the other, replace it in an equation to get a linear equation in one variable. I have 2 equations. Now, for suppose my equation is like this. I have suppose 2 equations, x plus y is equals to -2, 3x minus y is equals to 4. These are my 2 equations. Now, in substitution method, what do I do is, I will find the value of one variable in terms of other. Now, for suppose think that I'm using the first equation. From this, I find the value of y as x. Oh, sorry. 1 second. I'll find the value of y as -2 minus x. Now, this value I will substitute in the second equation as 3x minus of -2 minus x is equals to. Now, see, by replacing one variable value in the other equation, one variable value in the other equation, by substituting it, the second equation has become into a linear equation in one variable. That is a simple equation. All of you know how to solve the simple equation. So from this, find the value of x, replace that value of x in this scenario, you'll get the value of y. So this is the method how we solve this by substitution. Substitution method says to take one variable in terms of the other, use it in the other equation to find the value of both the variables. Moving further, we have the other method, which is elimination. Excuse me. What does elimination method talk about? Elimination method talks about use the 2 equations simultaneously, solve those equations either by adding, multiplying, whatever the way you want, you can operate it, but you can't multiply both the equations. This makes no sense. When you operate the 2 equations together, either by addition or subtraction, you have to operate it in such a way that one of the variable is eliminated from it. It is vanished. Only one variable is left over. You have to solve it that way. Now, for suppose, let's consider one more scenario. I have the two equations like this. My equations are x minus 2y is equals to 5. The other scenario is, let me take it as 3x plus y is equals to 10. These are my two equations I have. Now I have to solve it by elimination method. How will I do? I want to remove one variable. Think that I want to remove y. If I want to remove y, what will I do? Here I have 2 times of y. Here I have 1 time y. So what will I do is, I will multiply this equation with 2. And it becomes 6x plus 2y is equals to 20. The other equation as it is I will use, which is x minus 2y is equals to 5. Now on solving this, you can see if I add these two equations, I get 7x is equals to 25. X is equals to 25 by 7. See, by operating a coefficient equality in both these equations, I'm able to vanish one variable from the equations to get a simple equation again in one variable. That value of the variable is replaced in either of the equations to get the value of the y. Now I'll replace this x value in either first equation or in second equation. It will give me the y value. So this is what elimination method is. In this method, I'm removing one variable and reducing the equations in terms of the other to get both the values simultaneously. This is what elimination method is. Clear? Any doubts so far? Are you all able to follow, children? Okay, good. These are the various methods of solving. One is graphical method, the other two methods are algebraic method. This is in need when you are able to find the solution of the linear equations given page. Now, if the solution is not existing, like for example, we have seen in the case of if the lines are making a parallel line representation on a graph paper, you don't get any solution. But it is not possible whenever I get an equation, so I draw it on the graph paper, check whether it is parallel or not, intersecting, coinciding. It is not possible to check every time. So there should be some other shortcut to do that. What is that? Let's see. So some important observations we can quickly make just by looking at the equations. What are those? Now, if you have your two linear equations as a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, these are your two simultaneous equations. Now, first and foremost thing that what you are supposed to do is find the ratio of the respective coefficients a1 by a2, b1 by b2, c1 by c2. Respective coefficients, ratio you should find out. After finding the ratio, again here you get three possibilities. Why? We have three chances of lines being relating to each other. How? Intersecting lines, parallel lines, coinciding lines. Now for three different scenarios, the relation between these ratios also will be different. How is it? Now, if x coefficient ratio is not same as y coefficient ratio, here you can see a1 by a2 is not same as b1 by b2. In this case, these lines will be intersecting. Once they are intersecting, they will have one solution. Once they have one solution, we call such equations as consistent equations. So we call them as consistent equations. The second scenario, what happens is if a1 by a2, b1 by b2 are same, that is x and y coefficients are ratio is same. Again, constants ratio is not same. Have you observed it? X and y coefficients are making the same ratio, but constant ratio is different. In this case, the parallel lines will be formed. The scenario will be making up parallel lines. And इसके कोई solutions होते नहीं. They don't have any solution. And this type of equations are said to be inconsistent equation. What are they called? Inconsistent equations. Third scenario. When you have all the three ratios equal, A1 by A2, B1 by B2, C1 by C2, sub equal value there. Then what happens? You can see that they are coinciding lines. So in this scenario, how many solutions will be found? Infinite solutions banenge iske. Then we call them as consistent again, but dependent consistent. That is, one equation is depending on the other equation. I'll show you an example of all these type of equations. When will this happen? See here. Now, first suppose, let's take the example of the first scenario where you're getting intersecting lines like this. Now you have an equation like 3x minus 5y is equals to 11. 4x plus y is equals to 8. Now, what is the ratio of A1 by A2 here? 3 by 4. What is the ratio of B1 by B2 here? Minus 5 by 1. These both are no way equal. So, if you solve these equations, you will definitely get one solution for this. इसके एक solution तो बनेंगे क्योंकि इसकी graphical representation बनेगी intersecting. अब आते हैं second scenario. I'll show you an example for this also. Here you have the equations like this. 3x minus 5y is equals to 11. 6x minus 10y is equals to 20. अब देखते हैं इसकी कोएफिशिएंट रेशियो कैसे बनती है. We have 3 by 6 as x coefficient ratio and minus 5 by minus 10 as y coefficient ratio and constant ratio 11 by 20. अब आप देखोगे 3 by 6 and minus 5 by minus 10 are same, लेकिन constant ratio 11 by 20 के लिए unequal. This is a situation where you get two parallel lines and they don't have any solution. So we call their system as inconsistent system. अब आता है third scenario पे, and the example for this is going to be like this. 3x minus 5y is equals to 11. 9x minus 15y is equals to 33. अब ये equations बने हैं ऐसे. अब देखते हैं x coefficient, y coefficient और constant की ratio कैसे बनती है इसमें. 3 by 9 is x coefficient ratio. Minus 5 by minus 15 is y coefficient ratio and constant ratio 11 by 33. Sub की value same. This is a scenario where we get coinciding lines which leads to ultimately infinite solutions. इस case में we call it as consistent dependent equations. Why do we call it? आपने notice किया है तो आपको पता चलेगी second equation is just obtained by multiplying first equation with 3. Every term of the first equation, when I multiply with 3, I get the second equation. ऐसे equations को हम बोलते हैं consistent equations, but they are dependent. They are dependent equations. Why? Because one is framed from the other. Such equations will result in coinciding lines leading to infinite solutions. Clear? चलो आगे बढ़ते हैं. Here we have. Let's solve a question and see what are the scorings for various steps in solving that question. Here is a question. It's a word problem. 1 second. There's something going wrong in this. One second. Just give me a second. I'll stop my screen sharing and again I'll share it. Just give me a minute. I'll just share that previous question again, which I was supposed to explain the weightage. I find some typo error is been occurring. So I'll come back to that question at the end of the class. So do not bother. So here we have another question. Let's see the weightage for this also. Do not bother. Here we have a graphical representation of this system of equations. Here I have two equations, which is x plus 2y equals to 3 and 2x minus 3y plus 8 equals to 0. These are the two equations I have and have to solve them graphically. So this is going to be a 5-mark question again. So let's see how are we going to solve it. So if you want to solve this, first and foremost, we need to find the 2 points which satisfy these equations. First equation, if I take x plus 2y equals to 3. In this, if I replace x value as 0, I'll get my y value as 1.5, or which you can call it as 3/2 also. If I replace my y value as 0 in this, I will get my x value as 3. So the first ordered pair is going to be 0, 3/2. The other ordered pair is going to be 3, 0. So using these 2 points, I can draw a line and I'll get a graph. Similarly, second equation is, I have the other equation as like this, 2x minus 3y plus 8 equals to 0. So in this, if I replace x value as 0, I will get it as 2 times 0 minus 3y plus 8 equals to 0, which gives me my y value as 8y, making the point as 0, 8/3. Simultaneously, the other value, y equals to 0, if I replace, I get 2x is equals to minus 8, which leads y value as x value as minus 4, making up the ordered pair as minus 4, 0. You may ask me, Mom, this is 8/3, which is leading to a approximated decimal value. So is that good to use it or not? So if such scenario is occurring, don't worry. Do not use x value or y value as 0. Replace it with something else. Now, for suppose, if I try solving this as minus 1. Now, if I replace x value as minus 1 in this case, what happens? 2 times of minus 1 plus 8 is equals to 3y. So 3y is equals to 6, y is equals to 2. So I can use the ordered pair minus 1. So if you are getting this type of recurring decimal as one of the ordered pair value, do not use that because your line goes approximated. So pick out integer values so that you get an accurate line. Clear? Now, likewise, using these 2 points, you get a straight line. Using these 2 points, you get another straight line. Are they intersecting at any point? How are they intersecting and what is the point you need to observe? And if you have understood the chapter clearly, before going for solving this graph, you can directly visualize whether this is going to result in intersecting lines, parallel lines, or coinciding lines. How? I've given you just now the shortcut. A1 by A2, B1 by B2, and C1 by C2. So if A1 by A2 and B1 by B2 are not equal, definitely they will be intersecting lines. If A1 by A2, B1 by B2 are same, but not same as C1 by C2, they will become parallel lines. Now let's check in this case what is going to happen. X coefficient is 1. In this case, X coefficient is 2. Now here Y coefficient is 2. And in this case, Y coefficient is minus 3. So obviously these both are not equal. So these the picturization of these two lines are going to be intersecting lines. Definitely you'll get one solution for that. Now let's see how is that graph going to look out for these two lines. Here you go with it. So these equations, if you find 2 points which are needed for us, you can choose any 2 points as I've said. And if you make them graphical representation, the lines are going to look up like this. And see where they are meeting. They are meeting at a point -1, 2. So here you get the intersecting point as -1, 2, which is also called as the solution of this equation. Clear? So moving further, let's see one more question. The sum of 2-digit number and the number formed by reversing the order of its digits is 99. If the tens digit is 3 more than the units digit, find the number. Okay. So this is the other question. So how are we going to solve? Let's take the 2 digits of the number to be x and y because it is a 2-digit number. X and y I can consider. Now what are the relations that we have? First, consider tens and ones digit. If this is x, this is y. What did they say? Tens digit is 3 more than the units digit. So I can make it as y is equals to x plus. This is what one equation I already have. The second equation. Now, if I want to frame this number using these digits, what would be my number? 10x plus 8. Why? Whenever you are writing the expanded form of a number, you multiply the tens digit with 10 and added the ones digit. So 10y plus x is the number. Now, if the digits are reversed, how will it become? X in tens place, y in ones place. Now, the reverse number form is nothing but 10x plus y. Now, what is the scenario talking about? 2-digit number and number formed by its reversing the digits. This both numbers if you add up. So here 2-digit number is 10y plus x and the number formed by reversing these digits is 10x plus y. This both if you add, you will get it as 99. So now we have to solve this. If you solve this, you can see it as 11x plus 11y is equals to 99, or you can simply call it as x plus y is equals to 9. This is the second scenario. Now, this both equations, if you solve, you will get the x and y value. So how can I solve it? The first equation, I will replace it in the second. I will get x plus 3 is equals to 9. X is equals to 3. Now this x value 3, if I replace it in my first equation, I will get y value as 6. So I have the tens digit, which is 6, and the ones digit, which is 3, making up the number to be 63. This is how I solve this question. Using the given data, first I made one equation on digit sum. Second, number and reversing digits pattern I followed to get the other equation. These two equations, if I solve, I'll get the 2 digits, making up my required number. Clear? So here you have the steps for this. Now, for suppose if it is a 3-marker question, so how will these marks be allotted to this question? First and foremost, for framing first equation, you will get a 1 mark. For framing the other equation, you'll get 1 more mark. And for solving both of them, you'll get 1 more mark. Totally making it as 3 marks. So this is how you solve it for a 3-marker. So now it's your question answer time. Here is a question. Solve this. This is an assertion and reasoning question. I'm eagerly waiting to see all your answers in the chat box. I don't want only a few to answer. I want everyone in the class to answer for this. Keep posting your answers in the chat box. Okay. I could see the right answers in my chat box. Very good. All the answers are right so far. Can I reveal the answer or anyone else need time? So let's see the answer for this. Here they said the pair of linear equations, whichever is given here, has exactly one solution. What is the meaning of exactly one solution? They are intersecting. When will they be intersecting lines? When A1 by A2 is not same as B1 by B2. Now this scenario is possible by replacing those values of A1, A2, B1, B2. We get 2P by 2 is not equals to 3 by 1. That implies P is not equals to 3. So to get one solution, that is this pair of lines to be consistent having one solution, P should not be equals to 3. But they said P can take any real value except 5, they said. No, it shouldn't be 5, it should be 3. So for that reason, this is a false statement. Now coming to the reason, a pair of linear equations has unique solution if the respective ratios of coefficient of x is not equal to the coefficient of y. So of course, this is the true statement which talks about consistent equations with one solution condition. So that is true. So A is false and R is true. This is the right answer. Hope all of you are able to follow, children. If you have any doubts, you can post your queries in the chat box. You can raise your hand. If you are following it and if you are feeling things learned easily, please share your opinion in the chat box also that you are feeling things easy and you are able to understand well. That also you can share it. So here is another question. It is a short answer type question. So start solving it. In the beginning, I found many answering in the chat box. The moment the class keeps on passing on, we will start lessing out answers. Why is it so? You should be as active as in the beginning as that of the end. Both the ways you should be active in the class. And I could find many new kids to the class today. There are many new students also. If you are there, good to see. Okay. Okay. I got an answer from Pratik. Yes, yes, it's absolutely right answer, Pratik. Very good. What about the others? Let's see who else is going to be sending me answer faster. Very good, Pushti. Why is this question a bit difficult? Only 2 answers in my chat box. Let's see how to solve this. Here you go. So the sum of numerator and denominator of a fraction is 18. The denominator is increased by 2. Then the fraction is reduced by 1 by 3. This is the case. So now if your numerator and denominator, if you consider this as x by y, we already have the sum as 18. X plus y is equals to 18. I have this. This is my first case. The other situation, my fraction is x by y. In this, if I increase my denominator by 2, the fraction is reduced by 3, 1 by 3, they say. Actually, my fraction was x by y. It becomes reduced by 1 by 3. So I'm subtracting. So how will I solve it? X by y plus 2 is equals to 3x minus 1 by 3x minus y by 3y. I will cross multiply and solve this. I'll get it as 3xy is equals to 3x minus y into y plus 2. Now, how will I solve this further? I need to multiply the binomial on the right side. I will get it as 3xy is equals to 3xy plus 6x minus y square minus 2. I get it out this way. So I have 6x minus y square minus 2y is equals to 0. Now I will replace the first condition in the second case. So I can replace x value as 18 minus y, and then further I will solve. So on solving that quadratic part, you will get the y value. Then again, you can solve out to get the x value. And your fraction is going to be 5 by 13 this way. Okay. So let's move further to the next question. Here you go with it. Here you have a pair of equations which has infinitely many solutions. When will these infinitely many solutions occur? You need to observe it, use a particular relation between coefficients and solve. So I could figure out the mistake in the very first question which we have started with the weightage. I will read that for you. Very good, Pushti. Absolutely right answer. Pratik is also right. Very good. Oh, Tanishka, you need to check out your answer. Yes. So fine, let's see answer for this. Yes, very good. Now here they have infinitely many solutions. So you will have A1 by A2 is equals to B1 by B2 is equals to C1 by C2. So here you need to solve it as P minus 3 by P is same as 3 by P is same as P by 2. So either of these first two cases. Now, for suppose, let me consider these both parts being equated. I will get it as P square minus 3P is equals to 3. Now, directly you can't cancel out 3P and 3P. You just need to make it as P square minus 6P equals to 0, making it as P into P minus 6 equals to 0. So this will give you a scenario of P with two values, 0 and 6. Second, try to equate this both parts. You get 3P, 3 by P is equals to P by 12, which makes you P square as 36, making P value as plus 6 or minus. Now, what is the common for both the cases? Plus 6. So, the value of P for this is going to be 6. This is how we solve it. Okay. Oh, here we have options also, which is option B. It's not K, it's P. P is 6. The next question is here. I think the answer is not going realistic. Check it out. So the question is about the age of father. Tanishka is absolutely right. Very good. And you're right, Pratik. So shall we see the answer for this? So now we don't know what is the age of the two children. Let the age of the two children be X and Y. Now the sum of these ages, 3 times if you do, this is the father's age. So child 1 is X years, child 2 is Y years, and the father's present age is 3 times X plus 1. After 5 years, the first child will become X plus 5 years. Second child age becomes Y plus 5 years. And the father age will become 3 times of X plus Y plus 5. Because his age is also increasing by 5. But in this case, what did they say? After 5 years, the age will be 2 times the sum of their ages. So whatever the father's age is there, 3 times X plus Y plus 5, this is same as 2 times the sum of these two kids' ages, X plus 5 plus Y plus 5. Now you have to solve this. You'll get it as 3x plus 3y plus 5 is equals to 2x plus 2y plus 20. So take the variables one side, constants to the other side. You will get x plus y is equals to 15. What is this? Sum of ages of the two children at present time. But the father is 3 times the present age. So 3 times of 15, you'll get your required answer, which is 40. So this is how we solve this question. Okay. Let's move on to a case study question. Here we have two schools P and Q. Okay, let me give out the question. Basing on this, you are supposed to solve the first question, which is here. Represent the given data algebraically. That is, you have to frame the two linear equations basing on the given data. It's about the price of the award which is given to the students who are playing cricket and hockey. So what would be the equations? We are supposed to write that first. Very good. Perfect. Very nice answer, Pushti. So it's a simple thing that you can see here. You have the two scenario where 5 children are playing hockey and 4 children are playing cricket from the first school. So you get the price of the hockey if we consider as like there are two scenarios, hockey and cricket, X and Y if you consider the cost of the price or the value of the price. Then from preschool, you get a scenario, 5 students of hockey and 4 students of cricket will ultimately get an amount of 9,500. Same way in the school too, a Q, what we have, 4 students are playing hockey and 3 students are playing cricket, which making up a price amount of 7,370. So these are the two statements that you get from this. Now, your second question for the same case is like this. What is the price amount of each of hockey and cricket? That is, you have to find the X and Y values by solving these equations. So either you can solve it by substitution method or elimination method, whatever method you want, you can solve. You have to find the value of X and Y. So your equations were like this. 5x plus 4y is equals to 9500. And 4x plus 3y is equals to 7370. Each ticket cost, I sure, because 5 hockey prizes cost and 4 cricket prizes cost make 9500. Each value can never be that much. Now it's making sense. I think that should be the values. Yes, right answers. Perfect. So now if you solve these two equations, you'll be getting x value as 980 rupees and y value as 1150. So the hockey prize cost or the award which is given for hockey game is each costing 980 and for the cricket is 1150, 1150. So the last question of this case study is here. What will be the prize amount if there are 2 students each in each of the sport? So you have x value, y value. You have to find 2x plus 2y value. That's it. Perfect. Perfect. Very good. So yes, if you replace the values of x and y for 2 hockey tickets and 2 hockey prizes and 2 cricket awards or prizes, you'll get your answers for 3 of these questions like this. 4,260 rupees is going to be your prize amount. So as I've been telling you, I'll show you the first question. There was a mistake in it. I'll just show that for you. I'll correct it. Here the question should be something like this. So at a direction at different speeds. This is what the incorrect part occurring in this. There was some typos, a technical issue. So this is what happening in the question. Now, what is this question about? This question is about there are 2 places which is at a distance of 180 kilometers from each. That is place A and place B. Now, one car starts from A and other starts from B. They both are starting at the same time. If these both cars are traveling in the same direction, they will meet after 9 hours. If both the cars are traveling towards each other, like if first car is traveling in this way, the other car is also traveling in this way. Like because you'll get the scenario like this. So A is traveling from here and B is traveling from here. Both are going in the same direction. They'll meet each other after 9 hours. The other scenario is they are both facing each other. In this case, they'll meet each other after 1 hour. Now, what is the speeds of the cars? Now, let's see how do we solve this question. Here, if you want to solve this, first you should consider the speeds of both the cars as x and y. So see, here is being solved here. I'll show you the text on screen directly because we are running out of time. So if I consider the speed of first car as x kilometers and the second car as y kilometers, I will make the following linear equations. How will I get? Now, the distance between them is 180 kilometers. If you consider the first scenario, when both are traveling in the same direction, how much distance will the first car cover in 9 hours? 9x kilometers, second car 9y kilometers. But Initially, when they started, difference was 180 kilometers. Why? Because A started from here, B started from here. After traveling for 9 hours, they met each other. A has covered an extra of 180 kilometers. So A's distance and B's distance, if you see the difference, it is 180, which leads to a linear equation of x minus y equals to 20. Second scenario, when they both are traveling in the same direction, they'll meet after 1 hour. In 1 hour duration, they totally covered this person some distance, this person some distance, totally, which is 180 kilometers, which is the second scenario. Now, from the first scenario, you have x minus y equals to 20. From second scenario, you have x plus y equals to 180. On solving these both equations, you will get both their speeds. This is how you solve this word problem. Now, if this question is given for a 4 marker or 5 marker something, how will it be? So this will be a 2 mark part, this will be another 2 mark part, and this will be a 1 mark part. Actually, this is not a short answer type, this is a long answer type, because you are studying the word problem, analyzing the equations, and then solving. So for analyzing the first scenario of same direction, you'll get 2 marks. And for analyzing the second scenario of opposite direction, you'll get another 2 marks. And solving the 2 equations of both the cases, you'll get 1 more mark to get the ultimate distances. This is how you solve this question. This is the weightage of it. Okay. So let's see your practice questions for today. These are your questions for today's practice. Take your screenshot. As already suggested, these 5 to 6 questions are the existing patterns which we have chosen from the board exam similarity or same cases. And for more practice, we have suggested you score more books, champion, and for still more extra practice, 100%. So make a practice by using all the questions of the respective chapters in those books. If you have any queries, do come back to us in the next session so that we'll clear your doubts. Okay. So here we have, oh, sorry, here, okay. I think there was a mistake. I'll just write, do not bother. I will write that equation for you. So here is it. Your equation is 2x is equals to 5y minus 11. The other equation is 5y minus 2x is equals to 30. Now, these 2 equations stand for what sort of lines is the question. Okay. So, basing on this, solve this questions, come back with your answers in the next session. And now I will reveal you the answers for the next, last session's practice questions. I've given you 5 practice questions. I'll give you the answers for them. So here are the answers for those. So your next session is going to be on chapter 4, quadratic equations. So keep practicing, stay tuned. Let's meet back in the next session on Friday from 4 to 5. Till then, bye.
So students, if anyone has doubts, they can raise their hands.
Yes, Pushti.
There was this question which was given last class for homework. The practice questions which were given. For the last question, I believe the answer which I got was something different from the answer which you had given.
For which chapter, dear? For polynomials?
No, ma'am, for real numbers.
Okay, just let me look out. Give me a second. I'll just try to share it.
It was the fourth question for practice.
So you had a fourth question. What was the answer that you were getting?
I was getting 7 pairs for that.
7 pairs for the fourth question of real numbers, isn't it? Let me.
Yes.